a short lesson. So stay with me for a couple minutes. It's a short lesson with a longer practice. So stay with me for a couple minutes, and then you'll have time to yourself. Today we're looking at special right triangles. So there are two types of special right triangles that we're going to look at. With these special right triangles, well, with any right triangle, what can we use to find the side lengths? What did we talk about yesterday? Pythagorean theorem. Now there are two types of special right triangles that we're looking at today that we could use the Pythagorean theorem for, but there's a little quicker, you could call it a formula or a pattern that we'll use to find the side lengths of these special rights. So we've got two theorems, a couple of examples, and there's no class kit today. You're just writing on paper.
Ooh, look at that.
So our first theorem, and our first type of special right triangle is a 45, 45, 90, which if you have that note packet, the one with the staple in it, on the front page at the bottom, you should have that theorem already down for you. Now, one thing to point out when you're looking at these slides, just to make it clear, I know most of you probably picked up on this, but SQRT is square root of 2. So Google doesn't let me put like the square root when I'm typing. So when you see SQRT, parentheses, that means square root. When we have a triangle that is a 90, obviously 90 degrees is all these are right triangles. But then 45 and 45, we do not need to use the Pythagorean theorem to find the sides. With this type of triangle, we know that both the legs will be the same. We can see x and x. And then we know that we can find the hypotenuse by multiplying our x value, or whatever that leg is, by the square root of 2. So let's see. One thing that you might want to add to that note packet, because I don't think it's on there, nope, is right here. I think this can be kind of helpful. It kind of gives you a formula. Hypotenuse equals leg times the square root of 2. Now, let's just think for a second. If they tell you that the hypotenuse is 37, well, I'll write it like this. If they tell you the hypotenuse is 37, then based on this formula, what would we need to do to find one of the legs? Where do we plug 37 in? Where would we plug 37 in? For the hypotenuse. Now, if we're solving for a leg, what would we have to do? Yeah, we have to divide by the square root of 2. So this formula right here, we'll get more and more used to these, but this formula right here can be kind of helpful to get started. So if we look at these two examples, find the value of x, write your answer in simplest form. Now, we're going to be dealing with square roots. We might have some square roots in the denominator, so we've got to remember all of our square root rules and how we write the square roots in simplest form. But I'll go through those as we go. For the first one, find the value of x. Write your answer in simplest form. First, we need to identify what side we're trying to find. So x is what? A leg or a hypotenuse? Hypotenuse. So what do we know when we have a 90, 45, 45, then how do we find the hypotenuse?
Both legs are 8.
Yep, both legs are 8.
It would just be 8 times the square root of x, right?
Close. 8 times something, the square root of something. The square root of 2. Yep, according to our theorem,
There we go, guys.
x is 8, and to find the hypotenuse, we multiply our x by square root of 2. So x equals 8 root 2. And this would be in simplest form. This is totally fine. Now if we look at letter B, what do they give us this time? What side do they give us? Hypotenuse. And if we look back at we could call it a formula here. Hypotenuse equals the leg, or x, times root 2. So to find the leg, we need to divide each side by root 2. And what would that simplify to? Just what number? 5. Yep. Now as we get more and more used to these, we'll realize we have a 90, 45, 45, that this is the hypotenuse and it's 5 root 2. We'll know right away all we need to do is divide by root 2 and we'll be able to get x really quickly. But to set this up as we're getting used to them, I think can be helpful. Questions on that example? Okay, you're halfway there. Our next theorem. It's the same type of idea, except this time we're dealing with a triangle that is a 90, 60, 30. So we see in a 90, 60, 30, we have, well, first thing, with a 90, 60, 30, we have a side that is the longer leg and the shorter leg, okay? If we look at our triangle and we have a hard time telling which one is the longer leg and which one is the shorter, how are we going to figure that out? What's going to tell us for sure which leg is longer? The angles? Keep going, because you're right. Keep going.
If the angles are bigger, this side's
Yeah, exactly. So whatever side is across from the 60 would be our longer leg. Whatever side is across from the 30 would be our shorter leg. So most of the time we'll be able to tell from the picture, and it's not like they're going to try to trick you with the picture. But also, if you just want to make sure, our longer leg would be across from the 60-degree angle. Now in this case, we have an x would be our shorter leg. So if x was 5 with our shorter leg, what would the hypotenuse be? If our shorter leg was 5, what would the hypotenuse be? Yeah, it'd be 2 times 5, 2 times x. What would our longer leg be? I see where you're coming from. But 5 root 3, that's all we can simplify it to. Maybe. Could be. But 5 root 3 is simplified. Again, I think adding this right here to your note packet would be helpful. I think that formula can kind of give you a setup. As you get used to these, you'll be able to just refer to the picture and you'll be able to solve these pretty quickly. I'll give you another second to get that written down in your packet. Does anyone not have a packet? Oh. My bad, you guys should have yelled at me like a long time ago. So you'll be able to get both of these on the test. The only thing that these don't have are examples on them. You can write those down. Yep. All right. Let's look at the example, and then we've got practice. And then that's it. Find the value of x and y. Write your answer in the simplest form. So, first thing we need to decide, do we have the longer leg or the shorter leg? denominator, the longer leg. Yep. So let's try to find x first. So if we have the longer leg, that means we have x times the square root of 3. So what do we need to do? Like 9 doesn't have the square root of 3 involved or anything like that. So what do we need to do to find x? If to go from x to here, we multiply by the square root of 3. What do we need to do? Yeah, to go from here to here, we need to divide by the square root of 3. Now, is this in simplest form? No, we don't like square roots on the bottom. So does anyone remember the big fancy word that we use to get the square root out of the denominator? What? I want you to repeat whatever you said. Oh, no, not quite. We rationalize the denominator. So to get the square root out of the denominator, we multiply the square root of 3 over square root of 3. And we get the square root out of the denominator. Does that ring a bell a little bit, even if it's a quiet bell? Not at all?
No, I didn't know you just did.
Yeah.
Really?
Here's the square root.
Okay, so let's backtrack for a second. Let's
Never
think
mind,
all the
I
way
know
back to
exactly.
virtual algebra last year. Well, maybe you weren't virtual. We don't like square roots in our denominator. Okay? So, to get the square root out of the denominator, what is, if we take, let's sidetrack for a second, 4 over 4, what does that simplify to? 1. So square root of 3 over square root of 3 is just 1, but we're writing it in a different form. That's why we're allowed to do that. So we multiply by square root of 3 over square root of 3 because square root of 3 times 3, square root of 3 times square root of 3 drops the square root and just gives us 3. 9 times the square root of 3 gives us 9 square root of 3 on top. And we're fine with square roots on the top of our fractions, but not on the bottom. So that's how it goes. We call it rationalizing the denominator. Now, can we simplify this fraction? Yeah, we can. So what? Yeah, 3 root 3. Let's look at rationalizing one more denominator. If I have 5 over the square root of 2, how would I rationalize that denominator?
Times the square root of 2.
Yeah, on top and bottom. Yep, so we that's how we get the square root out of the
No, I did turn it 4. That is.
which one of where?
Like when you just.
Oh, because I messed up. Good catch. Square root of 2 times square root of 2 is just 2. We need to get more practice at that today. Oh, we still need to find y. So we know what x is. How are we going to find y? Yeah, we take, whoa. Well, multiply what by 2? Hey, what are you doing? Why are you talking to Will about it? You're kind of interrupting everything and distracting me. So. How are we going to find y? Square root of 3. Well, we have a couple ways, right? We don't like this. Probably the easiest way would be to take our shorter leg and multiply it by 2. So here's our shorter leg. Multiply it by 2. Now, we can move things around, right? Yeah, because it's all multiplication. We can move things around. We just get 6 times the square root. what questions do you guys have? I know that square roots make things a little bit complex and we aren't comfortable working with those all the time yet. But do you think that we are going to be able to look at these diagrams and see how we would solve some of these problems? Potentially. Well, we'll find out because I need to see these 4 problems before you get the packet.